सो आज हम बात करेंगे कि स्पेक्ट्रोमीटर की हेल्प से हम एंगल ऑफ इंसिडेंस और एंगल ऑफ डेविएशन किस तरह से कैलकुलेट करते हैं. सो मीन्स टुडे आई एम गोइंग टू टॉक अबाउट दैट एंगल ऑफ प्रिज्म. फर्स्ट ऑफ ऑल इज angle of prism, angle of incidence and angle of not emergence but angle of deviation, how these two angles can be calculated using spectrometer. So first of all, let us understand what is the angle of incidence and what is angle of deviation. So suppose there is a prism suppose a ray of light is made to incident over it. Say a ray of light is coming, like this. Area of light is coming in this way, and what will happen, let us draw a normal to it, and the normal to it can be drawn like this. Say the normal is this one, this is the normal. Say this is the normal, and this normal can be drawn both sides. So now, since this ray of light, if this medium is not there, then this ray of light will go straight like this, in this way, if this medium. So that means, but if it is entering towards the, say it is the rarer medium and this is the denser medium, so that means it moves towards the normal, so like this. So that means the path followed by this ray of light inside the medium will be this one. But if this medium is not there, then this ray must follow this path. But now this is the angle of this say this ray is meet at this surface at this point, so the normal at this point will be this one. This normal can be drawn like this. So if this medium is not there, then this ray must follow this path, but it is going in the rarer medium, so that means it must deviate from its path, means away from the normal, means it must go like this, means it must move this direction. So that means this can or this ray of light will go like this. It follow this path. So that means this ray is representing incoming ray, just a minute. So yeah, this ray is representing incoming ray extended when this medium is not there, and this is the emergent ray. So angle between incoming ray, that is incoming ray means it is the incident ray, and the angle between incident and the emergent ray is said to be the angle of deviation. So that means when this is reproduced backward, means when this emergent ray is produced backward like this, then say it is, if it is produced like this and this is the incident ray, so the angle between these two rays is known as the angle of deviation. And say light is coming in this way and this will go this direction, means a part of this radiation will gets reflected also, it will go like this. So let us try to understand how this can be, means how this angle of incidence can be measured with the help of a spectrometer, and how this delta can be measured with the help of spectrometer. So let us have a look at a video. Say this is a spectrometer. Means this is spectrometer, light is coming from here, and this is a telescope. This is a telescope, and we will see the direct reading of this, means first of all for the vernier B1 and then for the vernier B2, without putting the prism over the prism table. Now when I have taken the direct reading, say before placing the prism I have taken the direct reading of this. Let me go back. There is a, yeah, so this is the place, means here it is a direct reading corresponding to vernier B1, and this corresponds to vernier. This is for vernier B1 and this is for vernier B2. And this is for vernier B1 and B2. Means without placing the prism, I have to taken the direct reading of this telescope, means where it is there. So for this it is at the place this. So for vernier B1, this is the vernier B1 and this is vernier B2 towards this side. So these are the screenshots which I have taken. So for the vernier B1, the reading will be, this is 50, this is 45. So it is this 45 is this is 46. Yeah, so this is the 46. So it is 46 degree. Reading for vernier 1 is the 46 degree. Let me write it down. It is 46 direct reading I have taken. It as just so it is direct reading for vernier B1, it is 46 degree, and the least count will be 1 minute multiplied by most coinciding value. So that means most coinciding division will be, yeah, this division is most coinciding, this division. So which one is this? Is the 5, 6, 7 and the 8th. The 8th division is the most coinciding division. So its value will be 46 degree and 8 minute. Means let me write it down. So it is plus 1 minute into most coinciding value. So it is 46 degree 8 minute is the value of the vernier B1. It is the direct reading. And when I try to look at this one, V2, for the B2 its value will be 0, before 0 it is 230, so it is 225, 226, yeah, so it is 226. So for vernier B2 it is 226. For vernier B2 it is 226 degree plus 1 minute is the most coinciding value. So it is 226 plus 1 minute multiplied most coinciding division will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so I think 8th division is the most coinciding division. Here again the division will be same. So 8th division is the most coinciding division. So let me write it down. Yeah, so it is 8th division. So its value will be 226 degree and 8 minutes. Its value will be 226 degree into 8 226 degree 8 minute is its value. So why I have taken the direct reading? Let us have a look at that what is the reason behind it. So I have placed the prism here. See, here the direct light is coming in this way. Just a minute. Yeah, so the light is coming in this direction. See, this is a light, it is made over this, and from this side I am looking at the reflected ray, and say this is the incident ray. So if prism is not there, then we can see. If prism is not there, this is a very important point which we have to keep in mind. So if prism is not there, then I can see the direct ray so if prism is not there, then I can see this ray is coming in this side. So this is a direct reading which I have taken, and this is the reflected ray, and from this surface I can see the emergent ray. It is the emergent ray. So why I have taken this direct reading? Say this is a normal which I have taken here. It is a normal at this face. So that means what is the angle of incidence? In this case, this is angle of incidence. This is angle of incidence, and this is angle of reflection, because this is a normal. This is a normal. This is normal. This green colored line is a normal. So that means what I did, first of all, I have rotated the telescope from this side to this. So this is the direct reading which I have taken, and then I rotated from this side to this side, and I have observed the reflected ray of light here. So that means, and if I try to look at, say, ray is coming in this way. Let me draw it separately. Say prism is placed like this. Say it is a incident ray which is coming this way. This is the incoming ray, and it is made to incident over here, and this ray is reflecting in this direction. This is incident ray, and this is reflected ray. This is coming from the collimator, and if it is not there, then I can see this as a direct ray. So to look at this reflected ray, I rotated the telescope in this direction. So first reading is this one, and another reading is this one. So that means when I moved the telescope from this position to this position, then what will happen? I have measured this angle, and let us say this angle is theta. And as I know that it is incident ray and it is the reflected ray, and according to laws of reflection, I is equal to R. So that means this whole of the angle is twice of I. And if I try to look at it, then theta plus twice of I is basically, it is 180 degree. So that means I am interested to calculate the angle of incidence. So it is I, and I is nothing but is equal to 180 minus theta whole divided by 2. This I am getting from this particular equation. So this is a way that how I can be calculated. Now to get the deviated ray, I have observed the ray from this side. This is the deviated ray. Sorry, not deviated, this is the emergent ray. Emergent ray, and here the refraction will occur. So that means if I produce this backward, then this is the angle of deviation between the incident ray and the emergent ray. So this we have to measure. So that means first of all I have to take the direct reading, then a reflected ray, position of the reflected ray, and then the emergent ray. So let me draw a table first of all after looking at this part. So that means how this angle of incidence can be measured first of all. So for that what I have to take, I have to take the direct reading, then I have to take the reading of telescope corresponding to reflected ray, and after that I have to take the reading corresponding to emergent ray. So I have to take the readings of both verniers V1 and V2. So first of all I have to take the reading of the V1 direct reading and V2 direct reading. Similarly I have to take the V1 reflected ray corresponding to and V2 corresponding to this one, and similarly V1 for the emergent ray and V2 for the this ray. So that's what I have to do. This is a very important thing which we have to keep in mind. Now let me call this as dV1, dB2 and RV1, and let us call it as a RV2 and EV1, EV2, whatever you want to call. This is just for the sake of simplicity. So as I have taken these readings corresponding to direct, so it comes out to be 46 degree and 8 minute, and here it is 226 degree and 8 minute. These are the readings which I have taken. Now let us go for the reflected ray, and as I told here, see, now I am rotating the telescope corresponding to a reflected ray. Yeah, this is it. Here I have seen the I'm just little bit adjusting it. Yeah. See, it is adjusted corresponding to reflected ray. Say this is the incoming ray and it is the reflected ray, right? So it is incident and it is a reflected ray. So this is the angle, and here I have taken the direct reading. So let me go back to my readings of which I have taken. Yeah, yeah, this corresponds to the reflected ray. reading corresponding to vernier B1. So corresponding to B1, its value will be, say it is 120, so this is 125 and it is 126, so it is 126 is this one, yeah, 126, and both are coinciding, so it is 126.5 is a direct reading, is a 126.5. so for the reflected ray for B1 it is 126.5 degree, so I can write down it as 126 degree 30 minute. So its reading will be 126 degree and 30 minute. And for this another one it is yeah, for the vernier B2, what was its value? Its value will be, for the V2 its value will be, say it is 300, so it is 305, 306, no, sorry, 305, yeah, 295, so it is 295, 296, 297, so it is 297 degree, and the most coinciding value will be 1 2 3, yeah, fourth is the most coinciding, so it is 297 degree and 4 minute. So it is 297 degree and the 4 minute. So V2 its value will be 297 degree and the 4 minute. So what I did now, I just put these values in the table. Yeah, so it is its value will be for the reflected ray it is 226 degree, no, sorry, 126 degree and 30 minute is its value, and for B2 its value will be 297 degree, it is 297 degree and 4 minute is its value. Now let us go for the emergent ray. So after this what I did, I just rotated this telescope from this to that another side, so then I can see this emergent ray. See, now keep on rotating it. See, now I am looking at the emergent ray from here, from this side. This is corresponding to emergent ray. That's it. So now I have seen it for the emergent ray, and so for emergent ray yeah, this is for emergent ray. So what is it? Say this value is basically, this is 355, so it is 356 and 357, so it is 357 and it is coinciding, so it is 367 and 30 minutes. So its value will be, so 357 degree 30 minute. So that means for emergent ray, what are the values? V1 is equal to 1, sorry 357 degree and 30 minute. And for this, what is its value? It is 175, 176, 177, 177.5. So it is 177.5. B2 value will be the value of B2 will be 177.30 minutes. So this is its value. So let me write it down in the table. So it is it is 357 degree and 30 minute, and here it is 177 degree, 177 degree and 30 minutes. So these are the values which I am getting. So what is theta now? Because I am interested to calculate theta. So if I try to look at this diagram carefully, then what is theta? So theta here is equal to direct reading, means direct reading of vernier B1, this one, minus RV1, or either it is this one or DV2 minus RV2. So this is theta. So that means theta I have written for the two verniers corresponding to vernier V1 and corresponding to vernier B2. So these are the basically means this minus this is basically is the this what we call this is theta. So that means 126 degree 8 minute, or it is 46 degree and 8 minutes. So it is basically it's a 0, it will cancel out with it 0 minute, and it is 12 and the 80 degree. So it is 12 minus 4 is basically 80 degree. So it is 80 degree is the corresponding to it, and corresponding to vernier B2 means I have to take the difference of these two values, means this is one value and this is another value, and their result is 226 degree 8 minute, and here it is 297. So 297 degree and 4 minutes. So it is say if I have taken it from here to here, so it can also be written as 296 degree and 64 minute, and 8 minute is subtracted from here and it is 226. So it is 56 minute, and here it is 0 and the 7. Yeah, it is 7. So it is 70 degree. Let me look at it again. Let me go back. I think I have mistaken somewhere. So this corresponding to the, first of all, it corresponding to, it is 60, 45, yeah, 46. It is fine. It is 226. It's fine. Then let me go to the reflected ray. Yeah, so it is 295, 296 and 297, and here it is 115. So it is 120. Oh, sorry, it is 115. So it is 116, right? So I am wrong somewhere here. So let me correct myself. So it is 100 and 216. 216. No, sorry. Yeah, it is 116. Yeah, this value reflected, so that means it is this one. So it is 70 degree. Yeah, so this value is 70 degree is the this angle theta will be 70 degree, and here it is 70 degree 56 minutes. So this is V2 which I am getting here. And now I am interested to calculate angle I. So angle I is basically this 180 minus theta divided by 2. So 180 minus theta divided by 2. So 180 degree minus theta. Theta is 70 degree. So it is 110 degree divided by 2. So it is 55 degree. It is 55 degree. So because theta is I is basically this one. This corresponds to vernier B1, and now corresponding to vernier B2, what I am getting corresponding to it is yeah, it is again 55 degree and 28 minutes. Again I am getting this one. Let me correct myself a little bit. Yeah, so it is 55 degree 28 minute. If we do little calculation, we can calculate angle of I corresponding to vernier B1 and B2. Now I am interested to calculate angle of deviation. Angle of deviation. So what is angle of deviation? So angle of deviation is, which is delta corresponding to vernier B1 and B2. So it is basically delta corresponding to B1 is equal to direct reading B1 minus EV1, and or it may be dV2 minus EV2. So the difference of these two values means I have to take this value and this value. So it is so it is 3. Let me take first of all because angle of deviation is this one, and I go to the 397, so that means 360 is coming there, because 46 is there direct reading, and then I rotate it to get the value of this, what we call angle of deviation towards this side. So that means 360 will be somewhere here, and then I move to this one. So that means I have to add for this V1 360 to this value, means yeah, so it is 46 and this is 360, so I have to add yeah, it is 360 to this one. So that means this is basically 360 degree, or I'm going backward, so it is 356 and 46 and 8 minute, it is equal to 6, 8 and 0, 4, yeah, 406. So the difference between this and this value will be I have to taken the difference of this value, so it is 357 degree and 30 minute. I have to take the difference of these two values now. So what it will be? So it is let me write down it in a 305 degree, and I have taken 60 from here, so it will become 68 minute. So it is 357 degree and 30 minutes, so it is 38 minute, and the difference of this will be, this is 9, this is 5 and this is 8, and it is 9, it is 3, so it is 4, and it is 0. So it is 48 degree, so it is 48 degree 38 minute, and similarly I have to take the values corresponding to this B2 and this emergent ray B2. So it is 226 degree 8 minute and it is 177 degree 30 minute. So let me rewrite down, it is 225 degree and it is 225 degree and it is 68 minute and 177 degree and 30 minutes, so it is 38 minute. It is again 48, it is 48 degree 38 minute, 48 degree 38 minute. So now what is the angle of deviation? Angle of deviation is actually average of these two, and similarly we can calculate the angle of incidence, basically this one. So it is the average of these two values, so it is 55 degree and 14 minutes. So the angle of incidence, or in other words I can say that that angle of incidence is 55 degree and 14 minute. Corresponding to this angle of incidence, angle of deviation will be equal to 48 degree 38 minutes, right? So that's what we are getting here. So this is a way that how angle of incidence or angle of deviation can be calculated. So now we can also reperform this experiment in a slightly different manner. Means what we have to do in that case, basically what we will say, set the set the spectrometer such a way so that angle of incidence may be nearby 55. Say here our angle of incidence will be 55 degree. So what we can do, we can set it in a simple manner. Say we tried with the say 50 degree, we tried with 51 degree, 52 degree, 53 degree and 54 degree and 55 degree, 56 degree and 57 degree and 58 degree and 59 degree and 60 degree. Means we set the spectrometer in such a way such that angle of incidence will be this one, and after that we calculate the angle of deviation corresponding to these different angle of incidence angles. So here we have to calculate angle of incidence, angle of deviations, and we will get the different values, and after that we will plot a graph between angle of incidence and angle of deviation, and we got a such type of graph, and we suddenly find out that we are getting a minima at a particular value of incidence, and what will happen at this value, means at the angle of incidence where delta is equal to delta minimum. At this situation, if we look at the angle of incidence of angle of emergence, then we can say that I is always equal to E. So for rest of the experiments we have to set the telescope at this position. So with the help of this small video you can calculate angle of incidence and angle of deviations, and we can plot this particular graph. So that's all for this lecture.